This is a work-through of Problem 2 on Exam 1 of Module 5 in the book Problem Solving Guide for Electromagnetism and Optics. This problem involves the flow rate of seawater through a pipe. The speed of the seawater is 2.5 meters per second. The typical concentration of sodium chloride in water is 35 grams per liter. We're going to assume that is the concentration. We're going to also assume that the seawater completely fills the pipe. If the flow rate of salt through the pipe is 20 grams per second, what is the inside diameter of the pipe? Sodium chloride is actually ionized, existing as positive sodium ions and negative chlorine ions. Since there's no net charge, there's no net current. But the question asks, what is the current of only the positive sodium ions in units of amps? Okay, let's start with a good diagram. There we go. A pipe. Speed of the seawater through the pipe is 2.5 meters per second. We also know the flow rate of salt is 20 grams per second. The mass flow rate of salt is 20 grams per second. This means that a 2.5 meter length of pipe will have 20 grams of salt in it. Let's invest some time wrapping our head around on this. So 2.5 meters has 20 grams of salt. There's our slug of water. Imagine a syringe pushing this water, 2.5 meters every second. If the flow rate of salt is 20 grams per second and the water is moving at 2.5 meters per second, this amount of water must contain 20 grams of salt. If you're not sure about it, pause the video and think about it some more. It's an important concept. Since the concentration of salt is 35 grams per liter, that's given. There's 20 grams in here. There's 35 grams in a liter. This section of pipe, this blue section, must contain 20/35 of a liter. That volume is 20/35 of a liter. We can calculate this volume in cc's just by converting the units. There's 1,000 cc's in a liter. So this volume is 572.4 cubic centimeters, and this volume contains 20 grams of salt. We can calculate the radius now because we know the volume of this cylinder, and we also know the length is 2.5 meters. The volume is 572.4 cc's, and that's pi r squared L. L is 250 centimeters. We're converting to centimeters because everything's in centimeters here. We can calculate the radius, 0.854 centimeters, which means the diameter, which is what the problem asked for, is 1.71 centimeters. So looking at this diagram, we really messed up with the aspect ratio of the pipe. This is supposed to be 2.5 meters. The diameter is only 1.71 meters. So the pipe is a lot thinner than we drew, but that's okay. We're just trying to understand the problem when we draw a diagram. Now let's do part B. We know that 20 grams of salt flows by each second. The molecular weight of salt is 58 grams per mole. The weight of sodium is 23/58 of the weight of the salt. So when 20 grams of salt flow by, 7.93 grams of sodium flows by. Now we need to know the charge on 7.3 grams of sodium ions. And for this, we need the number of ions. So how many ions are there in 7.93 grams of sodium? The atomic weight of sodium is 23 grams per mole. We multiply by, we go from moles to number, and we get 2.08 times 10 to the 23rd sodium ions. The charge on a singly ionized sodium atom is the electronic charge, 1.6 times 10 to the minus 19th coulombs. So we calculate that all the sodium ions in this slug have 33,200 coulombs. And they go by each second. So the current of the positive charge is 33,200 amps. That's a high current, but of course, it's exquisitely balanced by a flow of negative 33,200 amps from the chlorine ions. That's problem 2.